Hello, Evan. This is Andreas.
Hey, hello, Andreas. Nice to hear
How you
you.
doing?
Good, thank you. We have been speaking about your project with great inspiration, and you spoke with my colleague Drago. Uh,
Yes, a little bit on email. Yes.
yeah, and we have we have some questions that we would like to speak about this project with you. But for the
Okay.
starters, the Real Nose is a spin-off DARPA-funded MIT research. Can you
Correct.
elaborate a little bit about that?
Yes. In the 2010s, like 2010, 2011, somewhere there, DARPA had a big program. DARPA is the Defense Advanced Projects Research Agency of the United States government, and it had a big program called Real Nose, and it was aimed at beating the dog's limit of detection. It was a very well publicized program, not a secret thing, very well known, and everything was public. We created three prototypes. We took them there, we tested them, and we feel like we won against everybody, and including the dogs. But they was never continued to phase two, so we only knew that we could detect single molecules in a clean stream with high accuracy and very low at very low concentrations. But we had never tried it for like it would be in real world, with a lot of different molecules and noise in the olfactory spectrum, etc. So these were very tightly controlled tests. They didn't even allow us to touch our machines. We had to be outside the room, so they didn't want us to cheat with our own noses. But they showed that the basic technology could work, and this was already over a decade ago. Now, since then, we tried once before to use existing technology to do a diagnostic tool for prostate cancer using what's called gas chromatography mass spectroscopy. It's a big machine, and we showed that it can be done, and it can be done, and the AI can be trained alongside the dogs. And that was the final piece that before this, even if we could show, which we did, that we could capture single molecules and, just one molecule could trigger a reaction in our circuit so that we can see a change in current based on a single molecule interaction. That's now trivial. People do it all day long in the lab. It's not no longer the limit. It used to be the limit. What became the limit is that we couldn't train on every single molecule on this planet because there's an infinite amount. Literally, it's what we call countably infinite. That means that so long as there's still time rolling, nature keeps inventing new molecules that smell slightly different, but it's all constantly making them. A flower gets a mutation today, it will create a slightly different smell, etc., etc. So this keeps happening. But what we found is that if we use the current AI to kind of mimic the dog's brain, then we can make sense of this. So long as we have to give up on something. We have to give up on the idea that a single smell is associated with a single molecule, and
Mhm.
that you can add two molecules. You can add garlic and chocolate and somehow linearly figure out what that's going to smell like. So that doesn't work. So you have to
So,
give up on the
so
yes.
a Real Nose is revolutionary, really. So you already started, but can you explain in simple words how it works and when can we expect to use it in diagnostic laboratory?
Yes, very good question. So it works by using actually for the first layer where we capture the molecules that waft about in the air, we are using mammalian olfactory receptors. These are the same things you have up here in your nose. Your nose is not this, this is the snout. This prepares the air for being sensed by your nose, which is up here. You have two epithelia, very similar to your retina. Okay, you have two retinas, you have two epithelia, you have two nostrils that feed them, and the nose that we have created in the lab works similarly by having the same type of receptors that humans have, and dogs, and cats, and rats, and mice, and everything that is a mammal. We're choosing our receptors in such a way as to first go, because you can tune them, and the human has 400, the dog has 800, but you can choose a set of them that is tuned to specific types of smells, let's say. So we chose one that would help us identify prostate cancer from urine. So that medical application, we are actually going to be testing these devices with urine for the first time in real life, because we have tested them with urine from non-patients and they seem to work. But for the first time ever, historically ever, anybody will be done in May. This is the first time we'll ever try a mechanical nose to do exactly the same thing as the dogs, alongside with real urine from real prostate cancer patients. We haven't done that yet.
It's this is amazing because such a vast application of this is mind-boggling, and
Right? Yeah.
even more. Many people don't know that the same nose can be installed in Mars lander to recognize the traces of life. Is there?
Yeah.
Is it there already?
No, it's not on Mars lander. I don't know who came up with that, but NASA did reach out to me a couple of times. One time for Mars, and another time, believe it or not, for Europa, because the expectation is that if we drill through the ice of Europa, Europa is a satellite of Jupiter that has a thick layer of ice, over a kilometer thick, but under this ice is liquid water. So the expectation is perhaps there's life there. So they want to send a probe that will slowly melt or drill through the ice and then put something in there, maybe a camera. And they wanted to put my nose in there to look for scents. And I said, I stupidly said no. I said maybe there's other ways. So I gave them a bunch of other ways that could it would be easier, because yes, the nose could smell life, but think of it this way. I told them that this has happened before. People have tried to smell out the presence of life, and there was like this whole detector built back in the 60s or 70s, I think it was, before we even really had any proper ideas about exploration of space, etc. But what they did was they said, okay, well, let's let it loose in the Kamchatka Peninsula, where there's some tundra and stuff, which is plenty of life. It's on Earth, right? There's all kinds of bacteria and bugs and everything. Of course, it's kind of and this thing came back and reported there is no life. So I think that if you can want life, it's a lot easier to see the tracks of life with your eyes and cameras and things like this.
But do you have already some indication that labs would take it for real testing on patients or people who are coming with some
Well,
diseases?
I believe so, but there's no customers yet. We don't have it commercially available. Everything is just for us for now. So we're training now how to use it, how to make it, and the devices that we have created now are unlikely to be exactly the same when they get to the market. The business we've built around it is entirely focused on doing exactly that, but it will take a few years because number one, currently the engineering is there, but I mean the performance is there, but the engineering is not all the way to where just like an everyday human can push a button and it works. We want to make it as easy to operate as even easier than a smartphone. But if you're doing many tests, we wanted to operate like those coffee machines with a big lever.
Yeah. You
Even a
put them.
monkey can operate. Yeah, even a monkey. If a monkey can do it, then we're okay. But now it takes more than a monkey, so we're not
Okay,
okay
but
yet.
in May you said you will be having a first test, which doesn't matter
Yeah,
how it looks like, as long as it can be useful.
right. Well, it does matter what it looks like and how it works when you want to commercialize it and to
Okay,
give
yeah,
it to
I
many.
understand. Yeah.
Imagine the nurse has 10,000 samples to do in one day. They're not going to start there with little, screwdrivers unlooking every little thing. Currently, you need to remove 6 screws to change the chips, and there's 8 chips inside. So it's not really ready for mass, adoptance. But you're right that when it shows the correct performance, then the job becomes easier. Then you say, okay, what do I change about this to make it easier to work? Not how do I make it so that it works better. So right now we're in the making it to work better stage, but in May we will. That's when the big information will come. We have a few hundred samples collected already from people with and without prostate cancer, and they've been frozen for many months, especially waiting for this. And next week I'm actually going to be in England, where we have a partnership with medical detection dogs, and
Hmm.
they have for us. We will find out how many exactly when I go, but I think it's many hundreds of samples also from prostate cancer that the dogs have smelled, and the dogs have already diagnosed. So we want to train, okay, what the hospital says, but we also want to train one machine that behaves like the dogs and compare the two. I think the dogs are more accurate than any hospital test.
Okay.
That's my hunch, but we're not sure. Yeah, so we'll find out.
But we are changing our nose constantly as the other parts of the body. How often do you need to change your sensors?
Yes, actually, very good. The nose changes every 2 weeks, just like your
Every
retina.
two weeks.
Every 2 weeks. It's very fast. It's a consumable. It's like film, for an old timey camera. You keep making more and more and more of it. So we are definitely more than 3 weeks stable, but the actual number we don't know for sure yet.
Okay, so you are using on one part is sensors, and actual decision making is done by artificial intelligence.
Correct. Yeah, that is trained. using real samples from real patients. Yeah. Same
And
at the dogs. Basically, exactly the same protocol as people do for dog training.
and then you are not chasing single molecule, but you are chasing like a
Oh, no,
bouquet
that's what.
or the pattern of this.
Correct. So that's the big philosophical and scientific change is this that we've recognized after first building a few noses. In the process of building them, I call it build it to understand it. In the process of building them, I understood, and the team understood, that we had the wrong idea. We thought the nose was an analytical tool, meaning that it gave you the information about which molecule it is and how much of it is. So the name and the concentration. We thought that the nose, when you smell something, and just basically gives you a list of ingredients, yeah, by name and concentration. But that's not what happens. You get a perception. You get a almost like a shape, an object in olfactory space that then you can remember and you can compare it to a new smell and say, "Ha, is this like a rose that I've learned that smells like this?" And it's much more like vision than it is analytical chemistry. Analytical chemistry, by definition, gives you the ingredients.
Hmm.
So what something. That's not the same question as what is something smell of. Okay, those are two different things because it's more like think of the molecules that go into a smell as the font.
Hmm. Hmm.
Smell itself as the word that the font writes.
Yes,
So
yes.
I can word, let's say stop, on the big red stop sign, and you understand that means stop because of your experience. Okay, then you go to a different country and maybe it's spelled in Arabic now, but you still figure it out even though not a single word is it because of the context and because of the shape of the thing. So that is completely absent if you think that one smell is one molecule, but that's exactly what happens in real life. When you smell different smells, you can actually many times you can smell the absence of something. How can you smell the absence of something? Well, the same way that if I show you my hand like this, look, you're looking at the absence of this finger. You're expecting this finger, right?
And it's not there. Yeah.
Yeah. So I'm using the fourth finger. Okay, don't be insulted.
It looks simple, but scientifically in laboratory to get to this conclusion, it's a hard and big step forward. Now, when you have a lot of experience in artificial intelligence, I wanted to ask you a rather little bit off question, which is what are the limits of artificial intelligence? If we put all rhythms of the nature, all system of seeing of future of system and humans, how powerful the computer has to be to see the future events as seen in, let's say, the Minority Report, theoretically, of
Yeah.
course.
Well, I think there's something to that. It's not a complete fantasy that the human coupled to a computer together, or even just a computer, um, could predict better than what we're used to. But prediction is a bit of how should I put it? A lot of assumption goes in there. And if your predictive tool is so very strong, it's kind of like the stock market. If you have a predictive tool for the stock market that is so very strong, you immediately become so strong that you influence the entire stock market so that now it's taking into account the fact that you exist and adjusts to it. If you have a very strong predictive tool, either you will use it to predict the future and become so very powerful that then the future must bend to your will and something will, if you want to break everything, something will rise up and fight against you. Like all nature, for every action, there's an opposite in direction and equal in magnitude reaction. That's Newton's third law. So I'm not so afraid of any of these things. Also in the recognition that there's not much you can do absent, what? I mean, I don't know what you can do to really stop it. It's the same as saying, well, a volcano might blow up. There might be a giant earthquake in San Francisco. Yeah, there might be. Okay, I know. There's also, what else? If you want to worry about things, because a lot of people worry a lot, and I think that's the message I want to give to people: is worrying is not going to get you anywhere. It's really a fantastically negative use of time and painful, and it's self misery that we create. And I tell you this: people are worried about AI. Oh my God, Terminators, la la la. Yeah, okay, all this and more will probably come. And we've seen even worse
Yeah,
horrors,
yeah,
okay?
yeah.
And fine, because if you really want to think about it, just take the humanity perspective and go even zoom out a little bit, see the little planet, then zoom out some more, and know that from physics, from completely established science, this isn't some fantasy, we've seen it happen. There's events in the cosmos, such as two black holes collide, and they spit out this jet of almost light speeds worth of gas and other particles and light. And this jet cuts like a lightsaber through whole hundreds of thousands of light years, like leaves behind a line of devastation. Everything just evaporates wherever it hits. This could hit us at any moment. You want to worry about that too?
Oh yeah,
There's
yeah,
nothing.
yeah.
So we have to understand life is limited. Worries and fears are fine to kind of entertain, but find the positive in there, and to ask the scientists, oh my God, when what is going to happen? Can this be? Can that be? Everything can be. This is what science tells you. Everything, absolutely any horror you want to create can be created. The point is to choose consciously what you want to experience and not go ahead and create these horrors. Okay, look on the bright side, and then you'll experience the bright side.
And one of the finalist question is: everything in medicine started in Greece with Galen, and will it end in Greece with Mershin?
No, no. Greece, Greece is my motherland, and I love it. And I think it's even was Galen before Hippocrates. I'm not sure. Hippocrates, so as far as I know, at least for the West, is the first guy to at least, or the earliest record we have of somebody explaining how to diagnose by the nose. Hippocrates, at 300 and maybe 60 BC, has the following prescription. He says, have the patient, if you suspect the patient has tuberculosis, have them cough and spit on hot coal and then smell the vapors. And if the vapors smell like rancid beer, then it is tuberculosis. And if it's, something else, it's something else. So this is a very, very sophisticated way of doing it because it connects something that everybody has smelled in his society. Now, I don't remember the last time I smelled rancid beer, but it's something to recreate. I just make the beer, let it go rancid, and have a positive control. And then he tells me specifically to use something that the patient is emitting very easily, not telling me go do a biopsy or any of this other nonsense. Oh, you need an X-ray machine, and then burn it on the coal, which is a preparation of the sample, and then smell it using your own sensors. That's an amazing technology the guy
But
created,
you are not doing it.
we're not as smart as he is. He was even smarter. He didn't need any gadgetry or millions of dollars, right? He just came with everything he needed was right there. The patient, the coals, the nose.
Yes, it's beautiful. It was a great pleasure to speaking with you, and I wish you all the best for your research and continuation, because this is life-changing technology that you are developing. Knowing early for our disturbances in the physiology is the perfect way to remedy this, because when we get something about it's already done completely the job, the harm, then it's very hard. But if it is early done, then and it's so easy, like putting in a toilet and having to check you every day, or in a smartphone.
It can be around. You can put it as a smoke detector, in a whole classroom, and then say, "Oh, someone got COVID in here. Let's go find out." All sorts of applications. I think we're opening up a whole new sense. Like it's a superpower for humanity. We can open it up, and then it's like, wow, the whole world is different because we have devices connected everywhere. They have cameras. They have microphones already. Imagine putting a nose on every smartphone. Now we can smell the whole planet. We can see pandemics somewhere.
Yes, absolutely. And this is why what you said now, my colleague Drago Plečko called your invention like a super nose, not a real nose, but a super.
Got it. Okay, I understand.
That was by purpose.
All right, I've got to go, but good meeting you. And
thank you very much. Bye.
Okay, thank you. Bye.
Bye-bye.